When it turns red, okay. Recording has started, so welcome to today's tutorial. We'll be going through the 2021 exam, which is, I don't know what paper, but it's 2021. So the COVID paper. Yeah, it was horrible. But yeah, let's go through it. So question one, right, let's start with the very beginning. So question one. And remember, it's not a must for you to start at question one. You can start at the Memo. You can start wherever you want to start. Just start. So you don't have to do it in order because sometimes you get stuck on some questions. Remember, like I said, the mark allocation, right? It's equivalent to how many minutes you're supposed to spend on that specific question. If you're spending more time than the more minutes than the marks allocated, I'll advise you to move on to the next question. You come back to it. So C++ and Java are both high-level languages, meaning that they are closer to English than other languages, right? High level. So you can somewhat read the code like you'd read an English sentence. However, the compilation and execution process is different between the two languages, which is true. It's different because C++ is what I call a preprocessor, which runs the preprocessor directives and things like that. Then you have compilation, then you have linking. C++ has linking. Java, though, I think it has linking. Not sure. I forgot the dag. I can't possibly know everything. I forgot that diagram. That's it. Remember that diagram on the slides with the shoe, like how the Java compiles and executes whatever. Those slides. I don't know that whole diagram. I know there's what I call a loader, a class loader, then compilation. Um, yeah, then Java for JVM, all of that. So discuss the compilation process when using Java. Your discussion must include the details of the tools involved, as well as the inputs and outputs of the tools. I said compilation, so Java C. So yeah, so this is how I would explain it. So if you remember, we talked about the commands that you run that they're actually programs, right? They're apps. If you go to the JDK folder and go to the bin folder, you see that Java C command and Java command, they're actually executables, they're apps. So if you scroll down here, you see there's java.exe, java c.exe. You see they are programs, they're apps. So when you phrase your answer, you're gonna say you call this program which takes in this certain inputs. So to compile in Java, right, um it doesn't matter how you phrase it. You can say like this, right? To compile in Java, you use the program called Java C, which takes in Java source code files as inputs and uh, and outputs Java bytecode. In you can let me see how I can phrase it in a clear way, but I'm trying to use proper English here. To compile in Java, you use the program called Java C, right? That's fine. Which takes in, so I'm gonna put a comma here, which takes in Java source code files that end in .java, right? As inputs and outputs Java bytecode. Um, it outputs Java bytecode. What words can I use? What word? I want to use the right word. It takes the file Java source code, which ends in .java, and then it outputs Java bytecode, which ends in dot class, right? Or you can say with the dot class extension or dot Java extension, they can phrase it in whatever way, as long as it makes sense. Basically, this is what I'm trying to say inside this one sentence, right? I'm basically saying this. Let me translate it to what I'm saying. I'm saying Java C, right? Space, and then you pass in the inputs, right? What are the inputs? It's anything that ends in a dot Java. That's basically what I'm saying, right? Anything that ends in dot Java. And then what you get back, or what do you get back after running this? You get back files that end in dot class, which we call Java bytecode. So you see, I was very descriptive. I told the marker that this is Java bytecode, and I know Java bytecode is stored in files that end with a dot class extension. So that's why I was very descriptive here, so that I don't miss any possible points, because you don't know where the ticks are going to go when they're marking your answer. And then that's basically the answer for A. They only said compilation, right? Compilation part when you're compiling Java code. Not when you're running, not when you're loading. They don't answer your own questions. They said compilation. So this is sufficient for compilation. You might ask yourself, this is small for 3 marks. Like I said, they choose where to put the ticks, those marks. So they're going to look at things like you said that this is a program. You understand it's a program. That's number one. And you know what it's called, Java C. You don't have to say Java C.exe. They know. The moment you said program, they know it ends in a .exe. You don't have to be, it's so obvious. You don't have to type that. Then, which takes in Java source code files that end in .java as inputs. Perfect. You're getting your marks there. And then outputs, perfect. Then you get your full 3 marks. Then discuss the execution process when using Java. Your discussion must include the details of the tools involved. By tools, they are meaning what programs run these things. So remember, in order to execute, remember execution, right? That's when it's another word for running the program. How do you run it? So another word for running the program or execution is to execute or run it. Remember, we use the we use the Java command, or the Java program, not command, the Java program. So let's do that. So to execute Java what? To execute Java bytecode, you use the program called Java, right? It's called Java. Remember, when you remember the process, you say Java C and then pass the files, then to run it, say Java main. If you still remember when doing batch files at the beginning of the semester and things like that. So this is yeah. So this is Java command, because this is going to be java.exe. It's a program, I mean Java program, because it ends in a .exe. And then this anything after the program, we call those inputs. So this file, you remember you just simply called it main because Java would add the dot class for you. So you didn't have to say dot class. So remember, you said dot class is Java bytecode. So you're gonna say the Java bytecode is the input into this program. So to execute Java bytecode, you use the program called Java, which takes in Java bytecode as input or inputs, right? And outputs the exe. Okay, there's quite a lot involved here, right? The execution process, no wonder why they give you 3 marks. The execution process is kind of complicated in a way, because what happens is that when you call the Java program, it calls another program too. So you need to, I don't know if you need to state that. So I'm gonna say that you call the Java, let me phrase it this way in a better way. You To execute the Java bytecode, you use a program called Java, which takes in the Java bytecode as inputs, right? Then these inputs become inputs. It becomes input or inputs to the class loader. No, not to the class loader. It is class loader per se, but I think the class loader is part of JVM. Yeah, I think the class loader is part of the JVM. So I need to say it becomes input to the Java virtual machine, right? JVM. JVM. Out the JVM then outputs the executable, right? With the extension um extension with the extension it outputs the executable with the write extension or with the extension based on the operating system. What I mean by this, right, is that let me do this. No, I need Paint. Yeah, I need Paint. Let me use Paint, the Paint app. So what I mean is that Java, right, it takes your your Java bytecode, right? So let's say this is your um, Java bytecode, right? So byte code, right? This is the bytecode. Then this bytecode, it gets passed into what we call the JVM, right? JVM, which is the Java Virtual Machine. Then the Java Virtual Machine is going to ask, itself or ask or find out which operating system you're using. So if you are using Windows, right, I'm gonna just say W for Windows, or if you're using Linux or Mac OS. Mac OS is basically MacBook, right? So it checks, and then depending on the operating system, if it's on a Windows, it adds a .exe, right? And then if it's on a MacBook or Linux, it's gonna be .out. That's how you know the executable. So the JVM, its role is to look at the operating system that's currently running this, whether that's Linux or Mac OS or it's Windows. And then based on that operating system, it generates the right executable with the right extension based on that operating system. That's basically what I've been explaining here. To the last sentence. That's what I'm trying to explain there. But then if you notice something whenever we have Java code, right, whenever we're running Java code, it never saves the executable, if you've noticed. So you can also mention that it doesn't save the executable. It generates it, right? But it doesn't save it. After it's done running the executable, it deletes the executable. Yeah, Java just does that. Um, wait, does it? Does it really? Yeah, it does. To be honest, I haven't seen an Java executable. Like, yeah, it does delete. I think the JVM does delete it, if I'm not mistaken. So, provide a definition of the Java virtual machine. Why does the why does Java make use of the Java virtual machine? Okay. So C, provide a definition of Java virtual machine, right? Like explain it. So Java virtual machine. This is the program that Java uses to execute Java bytecode. Because when you remember, we discussed it here, that is part of the execution, you use the JVM. So the JVM is the program that is used by Java to execute Java bytecode, right? You can say that, or you can. The thing is, I don't know why 3 marks. Why so many? Oh, it's 2 marks. It's not three, so it's not too bad. You don't have to go into deep. You can say that. That's one of the reasons. What else can you say? Um, this is all. This is all I can say. I don't know what else to say. I'll just say that's the program that Java uses to execute the Java bytecode. Not really. Let me say. Let me see. I think this sounds kind of wrong. Uh, let me phrase it this way. This is the program that Java uses, right, to generate the executable based on the operating system, then run the executable, right? That's basically what it does. It takes in that you can mention that it takes in Java bytecode, all of that. You can mention that that's not necessary. This is the program that uses Java to generate the executable based on the operating system and then runs the executable. Once the execution process has been completed, the executable becomes disposed, right? It becomes disposed, right? Or the it's a fancy way of saying it becomes removed, right? Or it disappears, or it deletes it. You can say it deletes, becomes deleted. Some yeah, say deleted. So it can say it becomes disposed, removed, or deleted. Because I've never seen it. Like after compiling and it says .exe, it's rare. I only see .class. Because if I remember very well, I think Java Virtual Machine, it does delete the executable when it's done running. Why does Java make use of the Java Virtual Machine? Why? To achieve platform independence. Right? That's this main reason, to achieve platform independence. So that Java code can run anywhere. Okay, can be compiled once and run anywhere. If you read the textbook, you notice that this is the Wara philosophy, right? Which is one of the key traits of Java. Write once, run anyway, right? Well, you can say compile once, can be compiled once and run anyway. So that's basically the main point of JVM, because you can compile Java inside Windows, and then that Java bytecode, that .class file, you send it to someone with a MacBook. As long as that person has a JDK on their MacBook, they can run that .class file without having to compile it again on their MacBook. That's how powerful Java is. And it achieves that through Java Virtual Machine. So you need to explain that it achieves, we call that platform independence, meaning it's not dependent on a specific operating system. It can run on all operating system. So it's independent. And this operating systems or laptops, whatever, we call them platforms. So it's independent of the platform, independent of the operating system, hence platform independence. So I hope that's clear. So we are done with question one. Question two, yeah, the theory question is the child. If yeah, it's all about finding the right words to use. You need to use the right terminology and make sure, just double check if you've provided sufficient explanation for the marks allocated. Then question two. Question two. Do you also have A, B? Yeah, so A, we did talk about this, if you still remember. Describe how Java automatically converts between different numerical types. I did explain that Java uses okay, they said automatically, right? So they want to understand the automatic part, right? Not the manual part. The manual part is that's explicit, right? That's a different question. Here it's automatically. So we should talk about automatic. So it's called implicit casting. Another word for implicit, you can say it's indirect, but it's not necessarily a synonym for indirect, but you can view it like that. Like you're doing things indirectly, right? For example, let's say you want to say something to someone, but you're too scared to tell them straight to their face. And then you say, yeah, you know what? If I was some people, I wouldn't do this. Like you see, you're throwing indirect shots at the person. So that's implicit. So that's an indirect way of casting, right? Which is done automatically for you by Java, right? It's indirect. That means it wasn't done directly, right? You didn't directly cast. It was done indirectly by another program, which is Java. So Java uses implicit casting to automatically convert between numerical data types, right? Which means that it, okay, you don't have to say which means. You can say, yeah, you can phrase it this way. You can say this is only done. You need to specify what conditions need to be met in order for that automatic conversion to work. Because they say this is worth 4 marks. You must mention all the points. This is worth 4 marks. You must mention what it uses to convert. It uses what I call implicit casting. When is that applied? Because it's not always applied. So you need to specify what condition needs to be met in order for the implicit casting to be done. So this is only done when the source type, right, is smaller. No, no, is bigger. Not smaller, is bigger. No, it's smaller. Source source and target is two different things. Source is where it's coming from. Yeah. So source type is smaller than the target type. Remember, the target type is the type we're trying to convert to, right? It makes sense. It needs to be bigger. For example, let's say you have something you want to put in a container. You can't put in the thing you want to put, right? We call that the source, right? That's where it's coming from, right? That's the thing you want to put. You can view that as the source type. And then the target type is where we are putting it into. So let's say it's a bucket. If the bucket is not big enough, it should, in this case, the bucket should always be bigger than the thing you want to put in. For example, you take a toy, you can put it in a 25 liter bucket, right? Let's say it's a small toy. So you see that the bucket is very big. It can accommodate that source type because it's very big. But if the roles were reversed, right? For example, you take I don't know, a 1 liter bucket, if there is one, 1 liter. Yeah, let's say it's a 1 liter bucket, a very small bucket. And you're trying to take something big and put it in there, maybe a school bag. You see that a school bag is bigger than the small bucket. That's when explicit casting is required because you're trying to fit in something that's too big into a small container. So yeah, implicit casting is only done when the container you want to store it into is bigger, right? It can accommodate it. So Java automatically casts for you. So that's how it does that. So this is the proper way of phrasing it in English. You can mention more points. I don't know what to mention there, but that's how I would phrase it. Discuss the concept of string immutability. Immutable right? Let's talk about that. You see, English is very important. Immutable, it means um, cannot be changed. And then mutable, right? Can be changed. Remember, let's look at the one word, mutable. Mutable is basically the word mut plus. Yeah, I'm teaching you basic. This is a concept. Even people like Elon Musk apply. It's called first thinking from first principles. You can watch a video. I'll send you guys a link on that to understand how to master this art of breaking down things and understanding them at a fundamental level. If you did physics or science, it's like breaking down everything up until like atom level, or you can even go deeper than that, like string theory, and then you reason from there going upwards. That's basically first principles. You break things down to their fundamental truths. So it's something similar to that. Me, that's how I'm able to understand a lot of definitions of words, even though it's my first time encountering the word. Break it down. So this comes from mutation, right? It can mutate, it can evolve, it can change. Remember, mutation, that means you're changing that old thing into a new thing, right? It's mutating, if you understand English. And then able. So that means it's able to mutate, or it has ability of mutation. It's able to change. Hence mutable. Immutable is just basically the opposite. That means it can mutate, it can change. So when they say immutability, strings cannot be changed inside Java. I think we did discuss that when we were doing revision. We did strings. Go revise go watch that recording. I did talk extensively on strings. I think I did mention two diagrams a bit. But yeah, once a string has been initialized, right? So let me show you, let me make an example. Let's say you create a string called hi, right? Simple. So this is the string hi, and then you store it into a variable called y, right? So let's say that's the variable y. So what happens is that Java creates sort of like a pointer here to that string, right? If you update the string, since strings are immutable, meaning once they're initialized, you cannot change them. If you say hi and maybe you do string concatenation, right? Let me make an example. Let's say you declare a string and you say y is equals to hi, like this, right? Then you say, let's say create a string called x. Not x, let's use y again because I want to show you immutability. And I say y is equals to y plus space, comma, world, right? Let me do this. So it's gonna read as hi world, right? Because it's gonna take the current value of y, which is hi. So it's gonna take this and replace it here. But and I know we are using the same variable, right? The way Java operates is that it builds an entirely new string. So it does this, right? It says there's the string. It's like, okay, let's build an entirely new string. It comes here, it's like y, and then comes here, says another string, which is that string as hi plus world. So it'll be hi world somewhere here, right? So it builds that new string, but I'm gonna do this. I think it might not be, it's somewhat clear, should be somewhat clear. But if it's not clear yet, let me do this. Let me change the pointer. Let me use the same thing, right? Let me use the same variable. Let me not write it elsewhere. But so we have this pen. So I click on the pen. Let's use the yellow. So remember, it's going to be high. So it's going to be this. Okay, this is bed. Let me change the brush. Yeah. So it's going to be high, right? So there's the new string high. Yeah, remember I'm using a trackpad to write this. I'm not using a tablet. So it's world, some world, blah, blah. You get the point. What Java does, it's like, oh, there's a new string now. So it deletes this pointer like this, right? And then it now points to the new string. So it now goes, oh, so now we are pointing to this new one. But then what about this one? That's when the garbage collector comes in, deletes it. So every time, that's why we end up using what we call a string builder, because it's gonna waste a lot of space. It's gonna take, it makes the application slow. Imagine every time you concatenate a string, it builds a new one because the strings are immutable, they cannot be changed. So that's a problem. So I hope that's clear. So let me just close that. So they say describe string immutability, right? So string immutability is when a string is initialized, or when a string English, nah? When a string, okay, let me say this string immutability, right? Let me just write it this way and say once a string has been initialized, it cannot be changed. So Java creates an entirely new string object if, for example, string concatenation is done, right? So when you concatenate strings, it actually builds an entirely new string. So that's what string immutability is. It means that once a string has been initialized, it cannot be changed. Basically, it becomes read only. If you remember Visual Basic, if you did informatics, it becomes read only, right? Meaning you can only read it. You cannot change it. You cannot update it. So that means when you update the string, we actually forced to build an entirely new string because we cannot update some strings, the ones we've created them. You can obviously phrase it in way simpler English, that's fine, as long as they can understand your point. And then C, provide Java source code to read one line of input from the user in a console application. Wow, this is easy. They said one line to read one line of input one line of input to read one line of input from the user. Oh, the key here, you see, the key here is this. You see this part over here? They said to read one line. So you must use the read line function. That's basically, they gave you the hint there. They want you to, yeah, theory is very tricky. You can come out confident thinking you aced it, and it aced you. So it's line. They said line there. If you remember your code very well, you remember that there's a function called read line. So I'm gonna say, since we're reading a line, it's going to be a string. Because remember that line, if you remember code. So I'm gonna say line is equals to scanner dot read line. And they didn't talk about imports, blah, blah, blah. That's not the point. You guys must learn to answer questions. They said provide one source code to read one line of input from the console. Oh, they didn't. Technically they didn't. Yeah, but don't do imports. That you can declare a scanner. That part, that one is fine. I think that's where the other marks come from. Let's declare the scanner, and let me do this. Right, so I'm gonna say, okay, let me just do this here. So I'm gonna declare the scanner first. I'm gonna call it scanner. Yeah, yeah, you need to also declare scanner. I think that's where the other 2 marks. I think the 2 marks will mainly come from you declaring the scanner, because it's gonna be 1 mark for you to know that you need to use a scanner to scan input. Then system.in will have its own marks. So scanner is equals to system.in. Then another tick will go to system.in. they'll take on system.in because system.in, you've stated that you are referring to the standard input, right? You see, it's a console application and you've referred to the standard input. And then in the next line, you actually read the line. So this reads one line of code, one line from the user, from the console. And this system.in refers to the console. So you're gonna get marks there too. Yeah, so yeah, if it falls off, always ask yourself if these marks they feel like they are free, you probably haven't answered everything. Just remember that. Just trust your intuition. If it falls off, just know you haven't provided all the answers. And then D, name a data type that can be used in a switch statement. Remember, we talked about this when you're doing switch statements. You can any integral type. This is int, short, long. I don't remember long being listed. Not sure about that. And then we have char, we have string also. And then I think enum, yeah, enum should also be part of that. Yeah, enum should also be part of it. So this is a few examples, but they said one. So you should name one. But they said type, not enum is not a type. It's a construct. It's a topic. It's like a class. You can't say a class is a type. The name of the class is the type, but the keyword class itself is not the type. It's just the keyword. So here you have to actually use the type. So string, char, int, whatever. And then that's it for this. Then we go to question 3. Yeah, let's go to question 3. How many minutes have passed so far? 43 minutes. Yeah, I'm moving a bit slow, but it's fine. Because if you don't understand, you're gonna write your own spiritual things there. So can a print writer be used to write binary data? We've never done that, and we have maybe I could be wrong. The thing is, Java is so vast. Like that's the thing about programming languages. It's big. Like you guys think you guys are learning at UJ, or you're not learning anything. These languages are big. There's a lot you guys don't know about Java. It's big. There's also a lot that I still don't know, even though I know a lot in Java. But there's still, I don't know everything. Like this language is just big. So what I would advise you to do is that's why you have a study break to go practice to prepare. So right now you should do your research, find out what print writer is all about, what scanner is all about, because they can phrase it in this way, right? They can simply change it and be like, can a scanner be used to read binary data? They can simply change it like that. It's still the same question, but it has been slightly changed. So you need to understand both a scanner and a print writer. But print writer, we use it for text files. But like I said, Java can surprise you. You can never be entirely sure. What I would do, right? There's two ways. You can open Eclipse, or you can go to here and say print writer Java doc, right? For Java documentation, which basically explains that thing inside of Java. It gives you an explanation of that thing inside Java. And I will always advise you to go to Oracle because that's the company that owns Java. So I'm gonna click here. Uh, this is if you check here, it says this is JDK 8. That's old. Go to this one that says SE21 or JDK 21. That's the latest. Then you scroll down here, you'll find out more information about it here. So you see here, right? That's why I said it's very important to understand. Don't be too quick to judge and be like, nah, you can't do it. There's no way because print writer, it's only text file. Zero. They'll just give you a big fat zero. You never know. That's why Java, this is programming languages. If I was some people, right, I'll just choose one language. Stick with that. Only specialize in that one language. Leave all other languages. Trust me, the more when you specialize, you get paid more. So just become a Java enthusiast. Like you only focus on Java. It's fine. Remember, there's still school. You can learn like HTML, all those ones, still fine. But your main one, the one that you're always studying on your free time, is Java. Just eat Java one way. Because Java, you can use it to make websites as back on the back end side, right? You can also use it to make APIs. You can also use Java for mobile apps. Java is very broad. You can use Java for desktop application using Java FX or Swing. So yeah. So let's see output stream. The abstract class of super or stream of bytes, right? An output stream accepts output bytes, blah blah. Yeah, you can. Do you see that it's talking about output stream? Remember, output stream is bytes. It's related to bytes, which is binary data. So you see that there is a version of print write that can do that. So the answer should be yes. So yeah, it's surprising, but you need to check documentation. That's why this I said practice is very important. I'm also shocked because I thought it would only works with text, but like I said, you can never be too sure. You have to double check. So if we go back here, the first part of the question it says, can it write binary data? The answer is yes. So you can say yes. That's I think you can also say no, but I don't know. If you say no, then that means you don't know Java. Because you see, there it is here. There's the version of print writer that takes in this. So yeah, that means you don't know what you're doing. So yes, provide a reason for your answer. Then you can provide a reason. You say that there is a constructor. The print, you can say the print writer has a constructor as a version. Let me say a version of the constructor that takes in an instance of output stream to write bytes of data. And then that's pretty much all you have to do. There's going to be 1 mark for yes, 2 marks for the reason. So you just simply tell them what you've seen on the documentation. There is a version of it. Remember, this is a constructor, you see? It's even written here. All of these are constructors. So that's why in my definition, I said there's a version of a constructor that takes in an output stream to write bytes, of which I've fully answered the question. Then you move on to the next part. Discuss the role of the buffered input streams when reading a binary file. We did talk about, remember the important part here is buffered. You need to explain that it buffers, which speeds up the process of reading from a binary file. So what's the role? The role of the role is to buffer the bytes of data read from the file, right? To buffer, if you say buffer, there should be, since you remember your your answers are being marked by people who do code on a daily basis. So there's no way you cannot know what a buffer is. So you're gonna say the role of a buffer, the role is to buffer. We call that buffering. It buffers the bytes of data read from the file so that um, you do not read directly from the file back and forth, right? So basically, you don't go back and forth to the file because if you have direct access to the file, that creates what I call a performance overhead, right? Basically, your app becomes slow. That's the proper English terminology for it. Your app becomes slow. So you can also add that there and say which um, reduces the, or you can say which makes the app faster, which makes okay, you can say which makes reading from the file fast. Yeah, you don't have to use those big terminologies, right? You can use simple English, that's fine. But they call it performance overhead. We'll also still list performance overhead in the other when you when you get to design patterns. So next, so what I would do, right? It's because of time, right? I'm gonna start to move a bit fast on easier questions, right? So regular expression that matches all dress style, size, blah, blah. Yeah, I guess I was wrong with this question. It always says all, if you notice something, right? It says all of them. So despite it needs to match the examples that have been listed and other examples, right, in the future. So it should match all of them. So let's start. So it should be small letters, one or more, right? So I'm gonna scroll down here and be like, it's small letters A through Z, right? One or more, right? Okay, just give me a sec. Let me move to a different location. Just give me a sec. Okay, let's continue. Okay, okay, so where were we with regular expressions, right? So as I've stated, you're gonna choose, make sure the options that you choose, they should match all of them. The ones that are listed and the ones that are not listed. So at least now the question is a bit clear because it seems like they always choose all. So let's do that. So this is small letters, one or more, because the number varies, like, right? It changes. So we have memory, do we have airline? It always changes, right? So it's going to be small letters A through Z plus one or more. Or you can phrase it like this. Remember, it doesn't have to always be the same as my regular expression. You can say curly braces one, comma, and you don't put in any number here because that would mean infinite, right? So one or more. You can phrase it in that way. But I'm going to say plus just to make it look neat. And then after that we have a space. If you notice here, there's a space. It doesn't say a tab, but we know that a tab is also something that's made up of white space characters, one or more. So I'm gonna use backslash s, one or more. So backslash s plus, meaning one or more spaces. So even a tab would match, even one space would match, even two spaces, even three. So remember they said you should match all. And then the size is XS for extra small, small, medium, large, extra, extra large. Mm. What I can do right here, right? There's many ways. That's the thing. They said you must match all. As you can see here, these are capital letters. And these capital letters, right? It's up to you how you can phrase it. You see that it can be up to three. You can say maximum is three, right? You can do that. But what I'm going to do is I'm just going to say one or more plus. So I'm going to say it's a capital letter, A through Z plus. Done. One or more. Because they said it should match all. It might not be, remember, people are different sizes. You might need extra, extra small, which is XXS, right? And it's not listed here. So it won't match, which would be wrong. So let's just use capital lit. And then after the size of that clothing item, you have a space again, so backslash s plus. Then we're gonna have an integer, which is 2 digits, right? So it's exactly 2, but they say it should be, yeah, it's up to you. The size part, right? The size is always a 2 digit. I've never seen 3 digits, and I don't know what you are if you have 3 digits. That's impossible. So it's gonna be 2 digits. So what I'm gonna say is backslash d exactly 2, right? It has to be exactly 2. I've never seen a size below 2 digits. I don't know, unless I don't know. Okay, yeah, it can be. Yeah, it can be. Yeah, it can be for kids, right? But yeah, I think so. I'm not sure. But let's just say D plus. I'm not really entirely sure. If you're not sure, just put plus. And then we have this symbol over here, which is a closing, uh, yeah, it's closing double quotes, right? You can just put them like this, done, or you can escape them. Either way, it should work, right? I'm gonna just escape it. There's no need for me to do that. I'm just gonna leave it like that. And then after the double quotes, the closing double quotes, we have a space again. Um, yeah, we have a space, so I'm gonna come here, backslash s plus. Then we're gonna have a color, right? You could pick these colors that are listed, right? That's fine, but remember, I want to match all of them, even the colors that are not listed. So I'm gonna say capital letters A through Z plus, right? One or more. And this would be my regular expression because I'm trying to match all of them. You see that it becomes less descriptive. Like there's no, unlike with your practicals. Remember the practicals, you had things like you're putting curly braces in round brackets like this, then you'd use the pipe to say or and things like that. In this case, we need to match all of them, not a specific file we're trying to read. So what I would do, right, to make it a bit to give the document a bit some life, I'm gonna make it a screenshot instead of typing it inside Microsoft Word. Then I'll paste it here. There we go. Right. I think is there question D here? No, there's none. So we're going to the next question. Yeah, this question paper is long, especially if you have to explain. But if you're just writing, yeah, it's cool. Because I have to explain it, it's gonna seem like it's very long. Right. So this is question on 4, right? Yeah, question 4. So question 4 is basically listing Java programming constructs. Yeah. There's one way, but I know a lot of you are gonna miss. It's literally gonna go over your heads. This one over here, these 3 dots. This is only possible in Java, and there's a specific name for it. You can only know that name if you read the textbook. It's not there on the slides. Remember, slides are summary, right? So, but I'll list it here. I'll also mention it. So, and I'd advise you to avoid listing things that are obvious, right? For example, abstract class. I mean, we see that that's an abstract class. But things like implements, right? That's something else. So we have, I'm gonna remember I need to mention the line number. So I'm gonna say line 4. I see the keyword implements. So that's what we call realization of an interface. So I'm gonna say line 4. Line 4, this is the realization of an interface. Basically, you are implementing the interface, but they use the word realization, right? And then line 8, by now you should probably know what extends means. Line 8 extends. This will be generalization, right? You can call it inheritance, but on your slides, I think it calls it generalization. So line 8, right? This is generalization, right? Just generalization. It's, or you can call it inheritance, right? Yeah, realization, generalization. You see, it's rhyming there. There's no way you can fail that. You can't fail it. Even line 12 is also real, a generalization, but you can't list the same thing twice. You've already, if you, like I said, your answer shouldn't be the same. Someone might say line 8 is realization. Someone might choose line 12 instead of line 8. They're not wrong. They just different approach. Then, uh, yeah, and then line 17, right? These three dots, right? They're called var-args, right? So it's line 17, right? So line 17, these are called var-args, right? The var stands for variable arguments, right? Var-args, variable args, or variable arguments. And this is a Java thing, which simply means that this function can be called in two ways. You can pass an array, or you pass the individual values one by one, separated by a comma. Those are the two ways you can call this function, simply by putting these three dots. That means you can call it in two different ways. But if you don't put the three dots, you put in square brackets. That means this function strictly wants you to pass an array. So just remember that. And then line 18, remember, you see the keyword new. That's a Java. It's a Java. It's part of Java programming constructs, right? So that's what we call instantiation. So line 18, instantiation of an object. Or you can just call it instantiation. Instantiation should suffice. It should be enough. This is what we call line 22. This is what we call polymorphism, right? Because you see that we are using iMovable, which is, let me see. Yeah, it has to be, this has to be polymorphism, yeah, because this is the base class, yeah. Polymorphism. So line 22, right? It's what we call polymorphism, meaning this function has many forms, right? Because remember, we are using the base class, sort of like the base class type, yeah. And then this base class type, right? It's calling the move function, and then Java for some weird reason it's gonna what is this? It's going to find out which function to call based on the type of the child class. If it's a fly, it's gonna call the move function for a fly class. If it's an ant, it's gonna call the move function for the ant class, and it does that using polymorphism. So that's line 22, polymorphism. You could have found other things to mention. That's up to you. So I'm gonna list these ones: polymorphism, right? This is the ones that I picked up. You can have your own. That's still fine. And then we're done with that. Question 5. This is slides. I don't have time to be cramming slides. That's something you should do. This is something that has to do with cramming. There's no other way to remember it. So go cram that. It's definitely on your slides. So we have advanced Java programming, question 6. So let's go to question 6. Question 6. And then let's see, analyze the following Java code segment and answer the questions that follow. Right. So we have two methods. One of the methods, right? It uses what we call ARM, automatic resource management. And then the other one, it just basically uses the exists function. So basically it tests if the file exists. If it does exist, then we execute here. If it doesn't exist, it just simply or it puts an error or something like that. Then they ask you the question. So I'm gonna say A here, and then A1 is file not found a checked exception. Remember a checked exception, right? It's an exception that Java enforces you to check. So the code won't compile without you checking it, right? So the moment you click compile, it's gonna refuse. It's gonna show errors. Is file not found exception a checked exception? This is a simple yes or no question. If you look at this code, right? In this case, they are referring to the first function, first method, right? If you look at this method, we have a try catch. And if you remember, when you remember your practicals, right? Remember, you can't read a file without having a try catch that handles this exception. It means that it's a must for you to check it. Hence, it's a checked exception. So the answer is yes. So this will be yes. And then two. So two, for two, which method A or B, is the correct way to process a potential file not found exception? Provide a reason why you would use this method. To be honest, both methods are correct. You can choose either, but you must be able to justify your answer. For example, if you choose method B, to be honest, right, exception handling is good, right? It's a good thing, right, to handle, but it is what you call an overhead, right? It's expensive on the memory. Like it requires a lot of memory. So to be honest, method B can sometimes work. They said provide a reason. Method B can sometimes be perfect for us when we want to create a very fast application and we don't want that slowness that comes with exception handling, because exception handling makes the application slow. So we can talk about anything related to speed or how fast the application can be if you choose method B. But if you choose method A, you can specify that you just want it's up to you, right? You need to provide them the definition. Let me try to explain both, right? Let me say method A. And they said provide a reason, right? Which method? So which method is the first part, right? There's a question mark. That's the first part. That should be worth maybe 2 marks or so, or 1 mark, I don't know. And then the other marks should be providing a reason. So it's going to be 2, yeah, 2 marks, because they said provide a reason, not reasons. So they said it's one reason that you must provide. So it has to be something that makes sense. So I can choose method A, right? When the problem, I can say we can choose method A when you want, right? When you want to create a very robust and secure system, right? So basically, when it deals with security, if you have an application that whereby security is a must, like things like that, exception handling is perfect in that case. Like it's very robust, right? When you want a very robust and secure system, method A would be perfect. But method B is also still a valid approach. But you use this when you want to create an application that is performance. Is what's that word? Is it performance? I think it's performance. Whereby application that is performance intensive, right? No, that's not the right way. Okay, yeah, we can create an application when okay, use method B when you want to create an application where performance is very important, right? Basically, when you need the application to be fast. When the client says they want a very fast application, you can even use simpler English, that's fine. But method B, just know it's when you want speed, you want a fast application, because exception handling makes the application slow, right? Because remember, you can't be throwing and catching, throwing and catching, throwing and catching. That's a lot of throwing and catching. So that makes the application slow. So you can avoid that. And remember, every time you're throwing 32 bits of memory. Remember, objects are 32 bits inside Java. That this information that I'm talking about, it's on the slides. So each object, remember, file not found, it's a class. So you're throwing objects, you're throwing 32 bits of memory around, throwing it and catching it, throwing it and catching it. That's a lot. So it's heavy on the memory, right? It's very heavy. It makes the application slow or slightly slower. And then B, let's go to B. I don't know if you, let me see how far are we now. Okay, we're still good. It's 1 hour. Yeah, we're still good. So let me do this. So B, with regards to Java multi-threaded programming, provide a definition of a task and a thread. Discuss how these concepts are related. Um, yeah, a thread is okay. This is quite a lot for a lot of marks just to define the two things. Yeah, with regards to provide a definition of, then discuss how these are related. They're related in the sense that a thread runs a task. I don't know what they mean by that. So, yeah, I'm gonna basically phrase it this way, but you can also refer to the slides. So, a task, right? A task you could say that this is like you can say it's like a subsystem. Technically, you can say it's like a subsystem. Yeah, you can say it's like a subsystem, right? That does um, that performs a specific action, right? So that performs a specific action, right? That's what you could call a task. And then a thread